Here we're going to do an example of graphing a rational function that has horizontal ends. So in this version, this rational function is already in descending order on the top and the bottom. And it's not factored, so that's going to make it really easy to identify leading terms, which will help us identify the ends. Those are what happens as x gets big positive x values and big negative x values. So for the ends of this graph, as x gets really big, the numerator is dominated by negative x squared, and the denominator is dominated by 2x squared, which reduces simply to y equals negative 1/2. And so this is the idea. We're going to get horizontal ends for this function because y equals negative 1/2 is just a constant. Let's say it's down here. So the right end is going to be a horizontal line at negative 1/2, and the left end is also going to be that. So sometimes this is called a horizontal asymptote because really what we're doing is getting infinitely close to y equals negative 1/2 on the ends. Okay? But I just like to call it end behavior. It keeps things simple because really that's what it's always is happening when you look at as x gets big. It's end behavior. You just look at big x values and calculate the y values. Okay, so those are ends, but now we have to know the zeros and the multiplicity, so we have to factor this guy to do that. So actually, let's do a little bit of work here. Let's work on negative x squared minus 5x plus 6. The first term is negative, so I'm going to pull the negative out, making this positive x squared, positive 5x, and negative 6. And then if I factor x squared plus 5x minus 6, I get x plus 6 times x minus 1. So that's my numerator. My denominator, 2x squared minus 50. By the way, this is not a video on how to factor, so if you need to review factoring, make sure to do that. I'm assuming you already know how, though. On the denominator, we're going to pull the 2 out, leaving x squared minus 25, and then we'll factor x squared minus 25 as x plus 5 times x minus 5. So our function, the formula for our function ends up being on top negative parentheses x plus 6 times x minus 1, and on bottom 2 times x plus 5 times x minus 5. Okay, and each of those is to the first power. So those are all in odd multiplicities, odd sign changes. But now what we can do is we can use those zeros to cut up a number line, an x number line, to sort of chart the y values at these particular x values. So our zeros are negative 6, positive 1, negative 5, positive 5. So if I list those in order, negative 6 is first, then negative 5, then we got negative 4 is not a 0. The next one we have is positive 1. So negative 4, negative 3, negative 2, negative 1, 0, 1. And then the next one we have is 5. So 2, 3, 4, 5. Okay? So we've got our 4 zeros charted here, our 4 x values. The y values at each of those, that's what we need to look at next. So we'll look at the y values for each of the zeros first, and then we'll look at the y values in between each of the zeros. Okay? So we'll do that next, after we look at the y values at the zeros. So if x is negative 6, that's going to make x plus 6 0, which is on the top. So 0 on the top of a fraction makes the whole fraction 0, so y is 0 there. If x is negative 5, that makes x plus 5 0, which makes the denominator 0. You can't divide by 0, so that's undefined. If x is 1, then x minus 1 is 0, which is on the top, which makes the fraction, the whole y value, 0. Finally, if x is positive 5, then x minus 5 on the bottom is 0. You can't divide by 0, so that's an undefined y value. Okay? Now we'll look at the signs in between each of the zeros. Okay? The way to get started is with your ends. On the left end of my graph, my y values are clearly from this negative. So that means I can put a negative on the left end. And on the right end of my graph, my y values are also negative, so I can put a negative on the right end. Okay? And I even know if I go to graph this, let's go ahead and set it up so you can understand how to use this end behavior. A lot of students miss this. So I've got 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. So I'm just listing the x values that I'm really interested in. Then on this particular graph, I also have to list a y value. I better list negative 1/2, and maybe I'll put that right there. So that means on the very left side of my graph, I know it's going to look like that, and on the very right side of my graph, it's going to look like that as well. So I have part of my graph, I better use it. Okay, let's go back now, use the rest of our number line chart, and then we'll come back and finish the graph. Now each of these, remember, it's circled in red, they all have multiplicities of 1, so all of them have odd sign changes, right? Which means the sign is going to change every time you cross over a 0. So when I cross over negative 6, my y value negative turns into a y value that's positive. When I cross over negative 5, positive changes to negative. When I cross over 1, negative changes to positive, and when I cross over 5, positive changes to negative, and that matches what we have, so that's good. If it didn't, we know we'd have an issue. Now we have enough information to look at my graph, okay? I need to probably investigate what happens when I get close to these x values where y is undefined, okay? So let's do that next. So let's look at as x gets close to negative 5. As x gets close to negative 5, x plus 5 in the denominator gets close to 0. So that means my denominator is going to approach 0. When you divide by something close to 0, your y values are really big. So that means as I get close to negative 5, my y values are going to get big, either in the positive or the negative direction. So I will have a vertical asymptote at x equals negative 5. Okay? And furthermore, if I want, I can see that to the left of negative 5, my y values are positive. So I'm going to have positive big y values on the left side of negative 5. So my graph's going to do this, go up on the left side. On the right side of negative 5, my y values are negative, and they're really big when I'm close to negative 5. So on the left side, I'm going to go down next to this vertical asymptote. Okay? Similarly, when I get close to 5, as x approaches 5, x minus 5 in the denominator gets close to 0. So my denominator is still getting close to 0. So my y values again are getting really big, which means I have an asymptote as well, a vertical asymptote at x equals positive 5. So my y values get big as I get close to 5. On the left side of 5, I get positive big y values. So on the left side, I'm going to go up. And on the right side, I have negative big y values, so I'm going to go down. Okay? Now, the rest of the hard parts of the graph are done, the ends and the asymptotes. The rest of it should be pretty simple. When x is negative 6, we get a y value of 0. That's an ordered pair of negative 6, 0. That's just a point, very simple. And when x equals 1, y is also 0. So we get the ordered pair 1, 0, which is this point. Again, very simple. So now, all I have to do is go through and connect the pieces. To the left of negative 6, my y values are negative. I have to stay below the x-axis. But I know at negative 6, I'm going to come up here and hit this point. Between negative 6 and negative 5, my y values are all above the y-axis. They're all positive. So that means as soon as I cross past negative 6, I have to be above the x-axis. And then I know that I have to connect to this behavior near the vertical asymptote. Past -5, my y values are negative. So, well, I already have negative y values, and I can see that I'm going up. The next thing I have information about is at 1, I've got a y value of 0. I've got this point here. So I'm just going to keep going up until I hit that point. I have to stay below the x-axis until I reach that point. Between 1 and 5, my y values are positive. So immediately past 1, I have to go above the x-axis. I have to have positive y values. And then I can see that I have to come over here and connect smoothly to the, sorry, that's kind of wavy because I was drawing slow. I have to connect smoothly to that behavior near the vertical asymptote. Again, it's wavy. I apologize for the digital version of this drawing. Finally, past 5, my y values are negative. So I have to stay below the x-axis, but I've got this behavior near the vertical asymptote, and then I've got my end behavior already there, so I just connect to that smoothly. And this is the sketch of the graph. So really, end behaviors and asymptotes are the tricky parts, but just pay attention to your signs, your pluses and minuses. That will tell you if you go up next to a vertical asymptote or if you go down. And then you just connect the rest of the graph smoothly. Okay? So that's how you do this example.